Choosing the right tech stack for your product in a world of unlimited possibilities is extremely challenging. Let's imagine you have an idea for the next $1 million to-do app. You may have a vision for how you can plagiarize another product's front-end experience. But behind the front end, there's a ton of technical decisions like how do we authenticate users, which database should we use, how do we run trusted code on a server, and how do we handle security, analytics, and scale up as our user base grows. These decisions are hard to get right, and just thinking about them takes time, money, and energy that would be better spent plagiarizing other products' user experiences. When it comes to minimizing decision fatigue, there's nothing quite like Supabase. It contains everything most apps will need to build and run a production app at scale. This is what we call a backend as a service, where the idea is you, the developer, write and maintain as little backend code as possible. It costs about $0 a month to run until your app builds an active user base, and it's extremely developer friendly.
A tool that lets you use the whole bath without scaling, cutting, or gunning.
When writing code with Supabase, you'll find the platform is well documented and optimized to get features built quickly. But ultimately, everything is trade-offs. I've been using Supabase for just over a year, and there are certainly some drawbacks to the platform as well. In today's beginner-friendly tutorial, you'll learn everything you need to know about Supabase. You'll learn how to deploy a full-stack application. The app will be able to authenticate users with their Google accounts. Then users can securely modify data in the database, and every time that data changes, it will be automatically reflected in the UI in real time. We'll be using vanilla JavaScript for this tutorial. However, most people using Supabase are using a front-end framework like React, Angular, Flutter, and so on. Even if you're using one of those frameworks, I highly recommend following along this tutorial as well to get a full understanding of how Supabase works at the base level. With that all being said, let's jump right into things. We'll start with our source code, starting by creating a public directory and creating an index.html for our starting markdown and an app.js file that we'll use to script out the interactivity that we're going to implement in this tutorial. We'll start out with the index.html page and generate a boilerplate web page, and we'll make an adjustment to the title. Then we'll import the Supabase JS library via the script tag from a CDN. Normally, you'd install this library with npm and bundle it into your application using a build step. But for our example, we're just going to use these script tags to make things a bit more straightforward. Then we'll use another script tag to import our app.js file we just created with the defer attribute to make sure that the document has been parsed before we execute the code in this file. Next, I'm going to bring in some other dependencies we'll use in the tutorial, namely Faker that we'll use to generate random data, Bootstrap for styling, and then some quick additional styles. Be sure to check out the source code in the repository linked in the description if you want to dive deeper, because we'll be going through most of these files pretty quickly. Now that we have all our dependencies linked in the head of the document, we can focus on the body, starting with the title to put everyone on notice, and then adding a section to show when a user is signed out, and this is namely to give them a button to be able to sign in with Google. We'll also add a section to show their user information when they are signed in, so we'll be adding in our JavaScript ways of putting information inside of this user details div. Next, we're going to add a section for all of our things specifically. So this is things specific to the user, as well as a button to create things. Again, this section will only want to appear when a user is signed in. And then we'll want a final section to show all the things, regardless of whether the signed in user owns this or not. So this should be visible at all times as well. Now that the initial templating is all complete, I'm going to open up a terminal and I'm going to run the command npx nodemon with the extension options of JS and HTML, and the command option of npx http server with a port option of 3000. Once we run that command, we can open up a browser to localhost 3000 and see our application running. And as we make changes, that will automatically kick off a new web server, so all we'll need to do is refresh the browser to see changes as we make them. That about does it for basic project setup, so before we go into the next step, I'd like to take the opportunity to shill for subscribers. If you're not aware, I've worked out a deal with Fireship to create a Supabase course for Fireship.io. But little do they know, I'm going to be launching a rival product called SupaShip along with the course. So be sure to subscribe for more Supabase tips and SupaShip updates. We only need about 1.65 million more subscribers to supplant Fireship and take our place as the dominant ship.io on YouTube. So, make it happen. Right, now that that's out of the way, we'll continue with configuring our backend, starting by creating a project in Supabase. To do this, I'm going to sign into Supabase, and then I'll create a new project. Give it the name here. and create the project. Once the project is created, we're going to need to copy the anonymous public key as well as the URL. Once we have those, we'll go to our app.js file, and we'll use that information to initialize our Supabase client. So to do this, we're going to take the Supabase object that we created on our window via this script tag. And we're going to destructure out the create client function from that object. Then we're going to use that function to create our Supa client here. All we'll need to do is provide the URL and the anonymous key that we copied from our Supabase dashboard. At this point, our Supabase client is all set up. But because we want to give our users the ability to log in with Google, we're going to need to set up a Google OAuth application and add the application credentials to our Supabase dashboard. There's some extensive instructions available on the Supabase documentation site for this, but we'll walk through it quickly now as well. So head to cloud.google.com. I'm already logged in, so I'm going to go to the console. Here I'm going to select my applications and create a new project. I'm going to provide a project name to match the one we made in Supabase. And we'll select the project, and from the search bar, I'm going to type in OAuth, go to the OAuth consent screen. We'll click external here so all users can access our application. We'll give it an application name. We'll need to provide an email, so I'm just going to use mine. Same for the developer contact information, and we'll save and continue. There's some more things we could have configured here, but we're just going to step through the rest. Last step on the consent screen, we're going to click on Publish App here and confirm it. This will make it so any user can log into the application, not just users listed as test users. And then we'll go into Credentials. Here we'll create credentials and select OAuth Client ID. This is going to be a web application. We'll give it the name. We've given everything else, Supership Video. For authorized JavaScript origins, we'll give it the URI that we've been developing on, localhost 3000. And then for authorized redirect URIs, we're going to skip over to the Supabase dashboard, go into authentication and providers, scroll down to Google, click enable, and we're going to copy the redirect URL. And I'm going to add a URI to paste that in. That's our auth callback URI. And we can click create here. This will give us a client ID and a client secret. I'm going to copy both of those and we'll paste them into the Supabase dashboard here. I'll hit save. And Google Auth is now enabled. So the hard part's done. It's just JavaScript from here on out. I'm going to go into app.js file and I'm going to create a section in my code for HTML elements. And I'll declare the login button. And we'll get that from the ID that we set in our initial HTML template. Then we'll add a section for event listeners here. And I'm going to take that login button. I'm going to add an event listener for the click event. And then we're going to take the Supa client that we created and go into the auth object of that client and then sign in with OAuth and give this an option object with the provider of Google. And now when I click sign in with Google, I get redirected to the sign in process for Google. Note this is my daughter's account, so when I click on it, it's actually going to have me go through the full parental authorization flow. So I'll go through and do that here with my phone quickly. Cool. And now we've come back to the application. You'll notice that we still see the button to sign in, but if we inspect here and go to the local storage, we actually see the auth tokens here are set. So my daughter is essentially logged in at this point. We'll need to add some additional JavaScript to make this look correct, to make the UI reflect that she's actually logged in. I'm actually going to start by dumping in all of the rest of the HTML elements that we created an ID for in our initial template. This will give us access to each of the elements that we'll need to script out interactivity for as we're writing the rest of our scripts. Next up, I'm going to create an initialization section of our script as well as a section for function declarations. Inside of function declarations, we're going to declare 3 new functions here. The first one is a function to check the user on startup. And then if there is a user, we're going to write a function here to adjust for a user. So this is to adjust the UI elements for the user. And then a function here to adjust the UI for if there is no user logged in. So to check our user on startup, we're going to call this inside the init later. Once it's called, we're going to want to await a request to get user from the Supabase auth. And then we're going to destruct out of that the user object that's returned to us by Supabase. Once we have that, if the user exists, we'll adjust for the user. Otherwise, we're going to adjust the UI for no user being logged in. So when we have a user, what we want to do is we want to set when signed in hidden to false. We want to set when signed out hidden to true. We also want to turn the My Things section on. Finally, we're going to take our user details and adjust the inner HTML. So this is like some dynamic templating we're going to do here based on the user we're providing inside. So we're going to add a header with the user's full name. And then we're going to add the image with their avatar's URL. And then we're going to add their UID just for debugging purposes. When we want to adjust for no user, we're going to do the opposite of what we did above. So once these functions are implemented, we're just going to call check user on startup inside of the initialization part of the script. I'm going to hit a save on there, and now we can refresh the browser. We'll be able to see that the UI reflects that Avery, my daughter, is now signed in. But now if we want to click sign out, we notice that this isn't working yet. This is because we haven't set yet an event listener for our logout button. So let's do that next. We're going to take our logout button, and we're going to add an event listener for the click event. And then we'll simply take our super client and call the sign out method on the auth property. Hit a save, and I'll refresh the browser to get the new JavaScript loaded in. Now I'm going to inspect the network tab here and click sign out. We can see when we click the button, we actually do send the request to log out, but our UI doesn't actually reflect this yet. When we take a look at the application tab here, you can see the auth tokens are gone as well. So Avery is logged out at this point. We just have to have the UI reflect that fact. So to make our UI reflect that the user has signed out, we're going to use the onAuth state change method of Supabase auth. So this method is going to take a callback with the events that we're actually not going to use, and then a session that's going to include a user property on it, which if populated, we'll know that the user is now logged in. So because of that, we'll say if there is a session.user, then we'll adjust for the user and pass in that user. In the case that there is no session or there is no user, then we'll adjust for no user. So if you'll notice, we're using the same function calls that we did on check user on startup. So this way our code is reusable and we're not repeating ourselves in terms of repeating the same procedures that need to happen on initialization and essentially on a subscription to the auth state changing. So I'll hit a save on this one and we'll refresh the browser. Remember, we were logged out before, so now the application is correctly showing us on startup that we're not logged in. So I'm going to click login. Once we're not logged in, the UI now shows our user information, and if we click sign out, the UI adjusts accordingly there as well. Now that authentication is all set up on our app, let's move into the database. We'll go to the Supabase dashboard and go into the table editor. Right now we have no table, so we'll go and create a new table. We're going to call this one things, and we're going to start without row level security, but we'll add this in later. We are going to enable Realtime. And in addition to a primary key, we're going to give it a name. We can make this a text value. We're going to give it a weight, and this can just be a 2-byte integer. And last, we're going to give it an owner. And for this owner column, we'll create a relation to our auth database. Here we'll click auth users and we'll select the ID here. And this will create a foreign key where everything must have a valid owner as defined by our users table of the auth database. We'll hit save here, and that created our table. Next up, we're going to add some more JavaScript to our front-end application so that we can programmatically add some things to this table. We'll get started by getting all of our things when our app initially loads and displaying them in a table in the All Things section. To do this, I'm going to create an async function called getAllInitialThings. and then another function called render all things that we're going to call once we've retrieved everything from our Supabase server. We'll go ahead and create a object to store all of our things in memory on the application side, and then we'll call get all initial things from our initialization section of our code. So to get all of our initial things, we'll take a Supabase client and call the from method to get us a reference to our table that we made. Remember, that was called things, and we'll use the select method on here to select all the information from that table. That information will be stored inside of this data object that we're destructuring out of the promise returned. Once we have the data, we're going to iterate through the array of things that were returned, and we're going to take our in-memory dictionary of all things, and at the ID of each thing, we're going to store that thing. This will give us the ability to do a constant time lookup if we ever need to delete or edit one of the things in our all things dictionary. After we've populated all of our things, we can then call render all things. Render all things will create a table based off of the data populated inside of all things. So we'll create a table header. We'll add a row for our header columns and put in a name and a weight. And then we'll iterate through all of our things, sort them in order of weight. And then for each thing, we're going to map that to its own row with the thing's name and the thing's weight to correspond to the header columns we put up above. We'll then join that to create a string, and then we'll create our whole table using the built-in Bootstrap styling. And once we've created our table template, we'll put that into the all things list. We'll hit a save on that. If I refresh now, we can see that our table is being populated, but there's nothing in it yet. If we check out our network tab though, after hitting the refresh, we should see that we are actually doing a request for all the data of our things table. It's just our table is currently empty. To populate some things into our table, we'll add an event listener to this create a thing button that we created in our template. We'll start by creating a function to create a random thing based off a user. Remember, there's a foreign key constraint on our things to a user. So if no user exists, we're going to print an error message out to the console and then return. But if a user does exist, we'll return a new thing complete with a name created by Faker, a weight, that's just a random weight between 0 and 100, and then the owner based on the user's ID. Once we have our function to be able to create a thing in place, we'll then add the event listener to the create thing button. First, get our user, and then we'll create a thing from that user. And finally, we're going to use the Supa client to insert our thing into the things table. I'll hit a save here. We can refresh, and we can see as we create a thing, there is a request that went out to create a tasty metal chicken into our table. However, we don't see it yet. If I hit a refresh here though, we can see the tasty metal chicken shows up. This is because currently we are getting all of our initial things on initialization, but after that we have no listeners yet to the real-time data that we've enabled on our table. To add that listener, we'll start by creating two functions in our JavaScript, a function to handle all things update, and then a function to listen to all things. That function to listen to all things is going to take the Supabase client and listen to the public things channel. This maps to the schema of our database and the table name. And then we're going to listen to all Postgres changes for any event. So this is any update, delete, or insert on, again, the public schema and the table of things. And then we're going to handle all those things. Before we implement this handle all things though, we are going to subscribe. This is essentially going to turn on listening to all the Postgres changes events. If we wanted to, we could make a reference to this subscription and then call unsubscribe later if we wanted to. For our application, we really want to listen to all the things all the time. So once we have an update, we're going to handle it. And to do that, we're going to say first, if the event type is delete specifically, then we're going to delete that update's old ID from our all things dictionary. Otherwise, if it's an update or an insert, and we're going to use the new object to either overwrite or add a completely new entry to our dictionary at the new item's ID. Last up, we've made a change either way to our all things dictionary, so we're going to call render all things, and that's going to update the table to reflect any new changes that happened. Last up, we'll want to call our listen to all things, but we don't actually want to do it until we've actually got all of our initial things, because that function is predicated on our dictionary existing and having our initial things in it already. So what we'll do is we'll wait until we get all of our initial things and that is resolved, and then we'll listen to all the things. I'll hit hit a save here, and we'll refresh our browser, and we'll see that as I create a thing, they're being added to our all things table. Note too that this isn't specific to this one client. As you'll see, if we open up the Supabase dashboard and target our heaviest thing, the practical rubber salad, and delete this row, that our client updates to that change as well. This would be the same if we had another user logged in too. Now that our app can show real-time updates to our things table, we'll want to add some row level security, or RLS, in order to make sure that users can only insert, update, or delete their own things and not any other user's things. To do this, we'll go to authentication and policies. And here we can see RLS is disabled, so we'll start by enabling RLS, and then we'll add a new policy here. Use full customization, and for our first policy, we'll always say anyone can read all the things. This will apply to the select operation, and for the using expression, we'll just put true. So this will say that for the select operation, any user can get all the things. Hit review there, and click save to save the policy, and the policy has now been added for reading. Now we'll add a new policy, and we'll call this policy only owners can modify. We'll apply this to all. Here we'll use for the using expression the UID, so this is the UID on the authenticated user, equals to the owner. We'll also use this for the check expression. Click review here. And this is the actual SQL that's going to be performed on our table to enact this policy. That looks good, so I'll click save. And we now should have enabled row level security for our things table. So now that we have row level security in place, we're going to add functionality to our app to list all of our things specifically in this My Things section. And we'll also add to that table a button to delete those things now that it's safe to do so. So to do this, I'm going to copy a lot of what we did for all of our things, but specifically for My Things. So we'll start by creating a reference to a My Things subscription, because we'll actually want to turn this off if we ever log out again. And then we'll have a My Things dictionary listed here as well. Then we'll add some utility functions to the bottom next, getting my initial things, handling my things updates, listening to my things changes, and rendering my things. And finally, we're going to have some additional utilities here for a delete button template, delete at ID. So this will be used inside of our event handler for our delete button, and then a trash icon. So to fill these out, for get my initial things, we're going to get the data. We're going to iterate through the data and set it in the My Things dictionary, and then we're going to render My Things. Same as before, just now with My Things. And for handling My Things, again, if it's delete, we're going to delete from the dictionary. Otherwise, we're going to insert at the dictionary. And then call render again, because the My Things will have changed. Now for listening to My Things, this is going to be a slightly different, as if we already have a subscription, we're going to return without creating another listener. But after that, we're going to just listen to the public things channel where the owner is equal to the user ID on Postgres changes. This is the same with the added filter of the owner is equal to the user ID. And then we're going to call the same handle My Things update as we did for all things, and we'll hit the subscribe. So the last piece of this is we'll set the My Things subscription to the return subscription of the subscribe method. This way we can set it and unsubscribe from it later as we log out from the user. Next, we'll render My Things. This is going to be a table very similar to the one we created for all things, but with an additional column here, and this is just for the delete button. We're going to do the same thing with mapping over all the values of My Things. We're creating a new row. Again, here's delete button template that we're going to create next. Join those things and create our table and set it to the mythingslist.innerHTML. Then to create a delete button template, we're going to create a button with an on click to delete at ID. So that's going to reference this function we haven't called yet. So this is setting a on click listener dynamically that we're going to then tie to this new function, and we'll put a trash icon in there. So when we click this button, we're going to want to delete at ID. We're going to use the Supabase client here from things and delete where the ID is equal to the ID ID passed in. And finally, we'll just grab this trash icon. Last up, whenever we have no user, we're going to check to see if there is a MyThings subscription. If there is one, we're going to unsubscribe, and then we're going to clear out that subscription. Also, if we log in, we're going to make a just for user now async, and we're going to await first getting all my initial things for the user, and then we're going to start listening to the my changes on the user. So let's hit a save here. I'm going to refresh our browser. And we can see when the app comes back up that we now have our MyThings populated, and we can click on a delete. That is going to delete the item both from MyThings as well as from all the things. I'm going to bring up a new user now, and we can see that as Avery's adding things, my other user can see those new things in real time. And if we log in with Google, I can now create my own things, and Avery will see those as well. And because of row level security, if I try to hack my daughter's things by taking the Supabase client provided by our client and deleting her rustic rubber chair at ID 12, we can see that because of row level security, I'm actually unable to do so. But we'll see if Avery attempts to do the same thing using the UI, she's able to do so. Now that we've built our application, our last step is to deploy it. And while Supabase doesn't have built-in site hosting, it's pretty trivial to take our static site that we just wrote and host it via Netlify. So I'm going to log into Netlify and add a new site, and I'll click deploy manually. And if I open up the directory where we created our SupaFeatures video project, I can just drop that into the Netlify site, and my site is now hosted. I'm going to grab this URL because the one last step we'll want to do is go to our URL configuration and drop in our new site URL that Netlify created for us, so that once it's deployed, we'll be redirected back to where we came from. Now when we go to our application deployed on the web, we can log in and I can create things as I had been doing before. That's it for this tutorial on Supabase basics. There's a whole set of features that we didn't get into in this video that really make Supabase awesome, including TypeScript type generation based on the Postgres schema, full stack type safety, storage API, edge functions, self-deploying, and the Supabase CLI to create environments for local development, just to name a few. I'm going to go ahead and wrap things up here. If this video helped you, please like and subscribe, and be looking out for more advanced content on this channel as well as on Fireship. You know, throw them a bone. And keep an eye out for our upcoming Supabase course on Fireship.io. Thanks for watching, and I will see you in the next one.